Hello, my name is Ashley Mullings, and today I will be presenting on peptoid inhibition of bacterial growth. So, over the past decade, there has been an increase in antibiotic resistance, and if this issue is not controlled by 2050, there will be a projection of 444.1 million deaths across the world. So peptoids have been suggested as a viable solution to this problem. Peptoids are N-substituted glycines, which are typically structural analogs of peptides. And what makes these two different is that peptoids have their R variable group bonded to the N, the nitrogen atom of the peptoid, while the peptide has its R group bonded to the alpha carbon. This N-substituted amide is actually what makes it more advantageous over peptides as it allows it to be resistant to proteolytic degradation. So the objective of this literature project was to analyze what structural characteristics would make the most effective peptoids. In order to do this, JSTOR and ProQuest was searched and key phrases were used to hone in on the articles that would suggest the most effective peptoids. All articles were ensured to be peer-reviewed and not more than 30 years old in order to keep all the information current and more relevant to what is at hand. So figure 3 shows the structures used in the first study to compare one property of peptoids that would make them efficient, cyclic versus linear. LGS and CGS are actually peptides used as positive control to provide some comparison to see how well these linear and cyclic peptides would work against E. coli. So figure 4 shows that it's using the MIC values, which is the minimum inhibitory concentration, which is the lowest amount of drug that can be used to inhibit bacterial growth. And those were the values that were used to determine how well these linear and cyclic peptides performed. So figure 4 shows that the cyclic peptides performed very well against E. coli in comparison to their linear precursors. The cyclic peptides are in orange and their linear precursors are in blue. And it is shown where across all 5 samples, the cyclic peptides had performed a lot better than the linear counterparts. Another property that has been investigated is whether lengthening the side chains would also increase the antibacterial activity of these peptoids. And it is shown where an increase in the length is synonymous with an increase in the antibacterial activity. With the exception of the hexamer C6, the cyclic peptoids outperformed the linear peptoids across all the E. coli that was used. Another property that was investigated was whether fluorinating the side chains would make a difference in the peptide and also provide an increase in the antibacterial activity. Figure 6 shows the structures that were used in this study, and a varying amount of fluorines were used on different compounds to see how well adding more fluorines would be to inhibit the bacterial growth. And as can be seen in the table, compound 2 was the most effective at inhibiting the bacterial growth. And it is seen where compound 2 has 12 residues, which again relates to the point that lengthening the side chain does in fact have an effect on increasing the antibacterial activity. Compound 6 also performed very well against the 4 different bacterial strains, but what makes compound 2 slightly better than compound 6 is the fact that compound 2 had a longer side chain in comparison to compound 6. In conclusion, cyclization enforces conformational rigidity that increases specificity. And what that ensures is that the target is met every time whenever the cyclic peptide infiltrates the cell, and it increases its cell penetration. Fluorine also increases the hydrophobicity and antibacterial activity until a certain saturation point. Adding more fluorines beyond that saturation point will only render the peptide ineffective and will no longer allow it to increase antibacterial activity. A combination of fluorination and elongated hydrophobic side chains would constitute the most optimal design and ensuring that these side chains are between 6 to 12 residues. Thank you.